Galileo Galilei, a Renaissance man. Galileo is an Italian scientist known as the father of modern physics. His work in physics and astronomy still evoke debate after over 400 years. His role in promoting the Copernican theory and his trials with the Roman Church are stories that still require retelling. He's known for defending the Copernican system using the telescope to examine planets, dropping stones from towers en masse, and being the first real experimental scientist. He also helped in creating mathematical physics. His major claim to fame probably comes from his trial by the Catholic Inquisition and his role in the long history of the warfare between science and religion. This is no small set of accomplishments for one 17th century Italian who was the son of a court musician and who left the University of Pisa without a degree. Galileo's most well-known experiment was at the Leaning Tower of Pisa, where he showed all objects, regardless of their mass, fall at the same rate due to the force of gravity. He threw 2 stones, both with different masses, off the Tower of Pisa. And according to Aristotle, the heavier stone should fall twice as fast. If you were 4 times heavier, it should fall 4 times as fast. But in fact, what the Leaning Tower of Pisa experiment demonstrates is that Aristotle was wrong, and that no matter what the difference in weight, 2 heavy objects will fall simultaneously at virtually the same speed. If Aristotle was right, this could only happen if the larger stones were dropped from a higher point in the clouds, but at virtually the same time, or that the lighter ones started falling earlier than the heavier ones, neither of which seemed probable to Galileo. Instead, the simplest explanation was that, heavy or light, all stones fell simultaneously with the same speed due to the force of gravity.
3, 2, 1.
In the early 1600s, rumors of an invention made by a Dutch spectacle maker reached Venice, and these led Galileo to construct his first telescope in the July of 1609. It wasn't long before Galileo began to make a series of startling observations, including the discovery of innumerable stars never seen before, and mountains on the moon, the movements of which he carefully plotted from day to day. He soon published these discoveries in a book, The Starry Messenger, which caused an overnight sensation. His telescope also led him to discover several moons of Jupiter, which he named the Medicean planets, in honor of his former student Cosmo and the famous Medici family. Shortly after the release of this book, he was appointed chief mathematician and philosopher to the Grand Duke of Tuscany in Florence. As Galileo grew more comfortable with the telescope, he became more and more interested in the way our solar system was structured. His major claim was that the sun was the center of the solar system and not the earth. Galileo supported Copernicus's heliocentric model, which countered Aristotle's idea of a geocentric model. Eventually, more and more discoveries were made, like the fact that planets, at the time known as heavenly bodies, were not perfect spheres. These new findings posed yet more direct challenges to Aristotle's idea of the perfection of the heavens. Some Aristotelian astronomers refused to look through Galileo's telescope, and others even tried to deny what he had seen. The Roman Catholic Church was becoming increasingly concerned, and a young Dominican, Tommaso Caccini, was the first to denounce Galileo and the Copernican theory officially. A few years later, as concerns mounted, Galileo was officially advised by Cardinal Bellarmino on the Pope's behalf to proceed cautiously and speak only hypothetically about the Copernican theory, and not as if it was actually real. Galileo returned to Florence and continued to work on his book, but now he gave more emphasis to the mathematical aspects rather than to the experimental or physical aspects, just as the Pope had wished. But when the book finally appeared in 1632, it raised an immediate storm of protests, leading to Galileo's arrest and famous trial by the Inquisition in Rome. It found him guilty of having published a heretical book. In the end, Galileo had no choice but to repent and confess that he had gone too far. He was sentenced to life imprisonment, which he spent for the most part at his own house at Arcetri near Florence, under the surveillance of the Inquisition. Even so, Galileo in his last years now undertook his last and perhaps greatest work, his Discourses on the Two New Sciences, which has been described as the cornerstone of modern physics. When Galileo died in 1642, totally blind and almost 78 years old, Pope Urban VIII did not forget his feud with Galileo and refused to permit his burial with a suitable monument. Instead, Galileo was buried unceremoniously in the Church of Santa Croce in Florence. A few hundred years later, his remains moved to their present magnificent tomb, opposite that of Michelangelo, near the entrance to the church. Galileo's biggest influence on today's science is that he was willing to stick to his findings, despite the disagreements he had with the Catholic Church. While Galileo did not invent the first telescope, he did refine it to the point that he was able to see further than any telescope of its time. This allowed him to see into outer space as well as set the basis for the kinds of powerful telescopes that we use today. Without Galileo's original telescope, the Hubble telescope that has helped pin down the age of the universe, determine the rate at which the universe is expanding, and created a 3D map of dark matter, would be non-existent, and we would be centuries behind in space research as we know it. The basis of the Chandra X-ray Observatory was also built on Galileo's original research. Galileo believed that nature was inherently mathematical and that mathematics was the language of nature. He said that math was the key to understanding the reality behind the appearance of natural events. What Galileo achieved in revolutionizing physics was to show how observation, careful measurement, and attention to the structure of a given event all led to an appreciation of hidden causes that ultimately expressed the mathematical unity of all nature. Thank you for watching.